Hello and welcome to Big Data, a positive thinking webcast. It's our 5th positive thinking, and you'll have some fantastic speakers on the panel today. Introduce myself quickly. My name is Kevin Boris. I'm the editor of Thinking Highways magazine, coming to you live from London, England. And you'll tell, once I introduce everybody, where everyone else is coming from. It's a truly global experience. It's positive thinking. Before I do introduce our speakers, I do want to make a couple of points. You can, as the audience, you can ask questions throughout or at the end, but please, can one of the questions not be, will we get the slides? I'll answer now. Yes, you will get the slides. You can have the slides. All the speakers have said you can have their slides. And over the next few days, we will send slides to everybody. Also, this is being recorded, and you will also get a copy of the recording if you so wish. If we don't have time for all your questions, which is always possible, our system logs all the questions. We then send the questions to the speakers, and then you can get your replies in one go. We may put it in an article, or you'll see the replies. And all our speakers, as they did last time, will reply at some point. So none of your questions will be wasted unless they want about slides, because we don't answer them anymore. You do get the slides. Anyway, so I'll introduce our panel now. First of all is our regular panelist, Mr. Bob McQueen. Hi, Bob.
Oh, hi, Kevin. How you doing?
I'm good, thank you. Bob is based in Orlando, Florida, so we are some distance and many hours apart. But obviously, Bob being originally a Scotsman, we feel it's kind of a Britishness about us. So I do apologise if the jokes get out of hand, but they tend to. So thank you, Bob, as usual. And we also have from IBM, Mr. David Pickerel. Hi, David.
Hello.
Whereabouts are you in the world? Normally you're not at home. Where are you today?
Well, I've changed jobs, so I'm a bit home more often. I'm at home just outside Washington, D.C., next to Dulles Airport, so I can jump on a plane when I need to, but I am here in Washington today.
Perfect timing. Thank you very much indeed. Thank you, David. We also have from the University of Maryland, Stan Young. Hello, Stan.
Hello. Greetings from College Park, Maryland.
Thank you. And obviously, as I mentioned, University of Maryland, it was going to be Maryland. Stan is also the president of Trafax as well, which is correct, Stan? I just want to make sure
That's correct, yes.
Everybody's titles correctly. And also, stepping in at the last minute, thank you very much indeed, from Appian Strategies, Mr. Armand Ciccarelli. Hi, Armand.
Hello, sir. How are you today? Greetings from Washington as well.
Yes, and excellent. So we are quite well spread out, because, well, those in the States and myself in London, where it is finally sunny. We have spring. I don't know if anyone's read in the press, wherever you are in the world, but we've had no sun since about September. We actually have sunshine now, and it's 7 o'clock. It's extraordinary. I'm not sure what to do with it. Anyway, now I'm going to hand over to Bob, and Bob will be driving the webcast. I will be on hand to answer any other questions or to fend off any accusations that Bob sends my way. So, Bob, I'll hand over to you.
Thank you very much, Kevin. I'll try and live up to the great expectations you've set for me in terms of being derogatory and provocative.
Oh, please do. That's what you said.
I guess derogatory statement number one is you need to learn how to say Maryland. Not Maryland. Yeah.
Maryland. Oh, well, I just do it from the cookies. Sorry about that.
And if you're, I won't even get into how you say it if you're from Baltimore, which is, never mind. That's like.
Yeah, I guess
Merlin. It's Merlin if you live in Baltimore.
Merlin, yeah. I guess the irony is a Scotsman trying to teach the Englishman how to speak American. Yeah.
The irony was not lost. Thank you, Bob.
Okay.
Well, remember that next time I go to Edinburgh. No, I'm just kidding.
Oh, that was good. That was
Edinburgh.
Excellent.
Edinburgh.
No, I can feel Bob getting cross from here. Fantastic. Sorry, everybody for listening. I apologise. All attendees, we will talk about transport very, very soon. I'm sorry.
Yeah, there will be occasional outbursts of random humour, though. Yeah.
That's true.
Kevin, we're going in the order of David, Stan, Armand. Is that right?
That is correct. Yes.
Good stuff. I don't want to surprise anybody by having them speak out of order.
No,
But,
you're fine. It's
great. Thanks, everybody. Glad you could all attend. Big data seems to be a controversial term in transportation, and maybe because not too many people seem to understand what it is, and I think we should have actually produced some graphics for today or some representations of big data, like a glove puppet or two or some kind of representation, but maybe we'll do that for the next time. So without further ado, I'd like to hand over to David Pickerel, and he's going to say his piece about big data. Over to you, David.
Okay, I'm looking for my first slide here. Brilliant. Okay. And I'll give this, to some extent from the IBM perspective in terms of it. I mean, obviously we're going through in transport, having been in ITS myself for about 20 years on a global basis, much of it. I call it the second convergence. We've had over the past really generation, 20, 30 years, IT and telecom have largely converged into ICT, information and communication technologies, and the lines are blurred. I was talking to some journalists just a couple of days ago between what's media, television, entertainment, content. All of it's basically digitized in a lot of areas. Transport is kind of coming along in terms of how this convergence takes place. That's affected virtually every other aspect of our lives, and it really is a matter of taking the information, if you call it the superhighway or motorway we've built now, and bringing that to the level where it's affecting us, whether we're traveling on a bus as a transit passenger or a driver or on a rail system. How do we converge the digital world that we've, in the media and everything we've come to expect in bits and bytes in our rest of our lives into the transport world? And there's a lot of things that have to kind of be done as part of that component and ecosystem. And IBM being a data company, having been a data company and a big data company for over 100 years now, are coming in from the side of, to the picture I'm showing now, really to the right, where we've been in the digital world for a long time and kind of lived in cyberspace and mainframes and everything. We've done moon launches. We've done since the beginning of the last century, and now we're really focusing on how we integrate that with transportation. Really, the problem and the challenge has always been in ITS that we don't have data. We have too much data and data that we cannot largely use. Highway systems have loop detectors. There's people passing through toll beacons. On transit, we have people with automated fare cards swiping on and off, using their Oyster card in London, or using their Smart Trip here in the Washington area, or their Clipper card in San Francisco. How do you actually count and use the data? Where's the data going? How can it be used? What can be drawn from it? And it's, of course, quite a lot of data for any size system because it's every driver or every passenger. So there's a lot of tools that IBM's lined up at the bottom. We've got a sensors and meters. We've got to integrate it, and we've basically got to merge real-time data with historical data to develop trends and predictions and analytics around it. And then how do we model that? All of it being sensitive, as we must be in most of the developed world, to the issue of where's the line between privacy, between what data we really need to use, what data is either irrelevant or stuff that we don't want to gather because we don't want to invade our citizens' privacy. We need to operate transit systems that monitor our citizens. How do we do that? So that's kind of the ecosystem. Let me switch to the next slide here, I think. We could. And this is kind of how IBM approaches it. I mean, this is by definition our data-centric, IBM-centric world here. Basically, out in the ecosystem, we've got sensors, which are cars, drivers, even mobile devices can be sensors that generate and basically other sources of data. On the other end, sometimes the same individuals are both sensors and users, where they can provide location data, speed data, all kinds of telematics data if they have a telematics system in their personal vehicle or their commercial vehicle if they're driving. Data they put in, and then data they need to get back out depending on who they are in the system. Is it a traffic management center operator basically watching the M1 motorway or Interstate 95? Is it a public safety person trying to clear an accident or incident? Or is it an individual driver that needs decision tools to know as soon as possible, if not well in advance, what decisions do they make both directionally in terms of what routes they take or modally? All of that requires really kind of all the data all the time to distill it into something that's usable to whoever this user is in terms of what he or she needs to do with the data. So that's kind of comes down to where IBM is. Our mission, as it were, is to collect all of this data. A lot of it will come in through ICT networks. Mobile network operators have a lot of the data good data, anonymized data that can tell you the exact numbers of movements of people with the technology to not necessarily tell you, not at all, in fact, tell you who they are and give you, as I call it, full user demographics for an entire city or an entire transport network. So you bring in all that data and you apply the analytics to it, and then there's a number of things you can do with it once you've kind of got the data clean. You know, there's certain data that's going to be not useful. There's a bad loop detector. There's a malfunctioning cell phone. There's some other anomaly. You clean it up a bit and get the anomalies out of there and the noise out of there. You may want to blend in third-party content. If allowed, there's a potential for transport agencies to garner revenue for people that voluntarily want to have information sent to them. I'll give a nice Glasgow example. Someone's standing on a corner and they want to head down the Royal Mile. They're waiting for Lothian Transit to come by, and they want to know when the bus is coming. And they find out the bus is coming. It's been delayed by engineering work somewhere else in the city, so they're going to need to wait 20 minutes for it. But here it goes. There's a coffee shop directly behind them that serves their favorite latte. Boom, here's a coupon. Go in there, buy your coffee, drink your coffee, and get out of the rain. And then your bus will be there in 20 minutes. You can ride the bus. Everyone's happy. The rider's on the bus, as well as the bus company has their passengers, and the coffee shop has garnered a sale and paid some revenue to the transit agency. So there's all kinds of third-party things that can be blended in and used. When you talk about payments processing and getting away from what's always been, and I'm a transit person by background, very expensive transactions to basically have fare cards or a piece of paper or a token or a piece of something or other, to get from something that you can use your mobile device anywhere in the world, download the app, and then you can ride the tube in London or the subway in New York City or the DART system, light rail in Dallas, wherever you are, almost instantaneously with electronic fare media. And then areas where this data is important to emergency management agencies for disaster or incident response, sporting events like the Olympics, as was the case in London that we did some work with, and will be the case in Rio de Janeiro. How do you both plan and unplanned events? How can this transport data be useful, and how can the transport network get data out of the larger data ecosystem in the cloud to do that? Let me go to my last slide here. And again, here's just a couple of examples of how I've kind of talked about this already, and I'll move on to let my colleagues speak. But awareness, data feeds, where all these sources of data that are just rife across any transport ecosystem. Because of the fact that we control movements of vehicles and people by definition, we already generate the data. We don't have to go out and create the data. It's already there for us. Big data is in transportation whether you recognize it or you leverage it or not. So you might as well leverage it because it's always been there. It's been there since 200 years ago when they first started putting railroads and any kind of mass transportation system in place, in London since 1825 to be exact. How do you anticipate problems and get ahead of them? Real time is really not good enough. All of us have been on the motorway and see the VMS sign saying there's a big problem ahead, but by that point we're always sitting in a long queue or traffic jam. It doesn't do us much good. Rather, if we could go to our house and have the system tell us there is a big jam up on Interstate 5 in California, why don't you take the Caltrain in instead of driving today? It'll be faster. Or if you must drive, take Route 101, not Route 5, and steer around that to do that. So the predictive and incident detections. And then finally, how do you coordinate resources? Public safety and transportation operate in separate ecosystems all the time until there's a problem. When there is, they need to be able to work together immediately, resolve the issue, and then get back to business as usual as quickly as possible to keep the citizens moving and to keep the network going and do all that wonderful thing. So proactive management. So that's really kind of a nutshell as far as from my perspective at IBM, and I think as an IT person and as a data person as well as a transport person, there is to leverage it. And the message I'll leave with for now is the big data has always been in transportation. We're just basically being able to use it more, and the ability to use it is an inevitability in any market in any country. We just have to find a way of how and in what manner we want to play in that ecosystem. So with that, I'll hand it back to Bob to move us along here.
Thanks very much, David. Appreciate that. Some food for thought. you and I need to talk about the difference between Edinburgh and Glasgow at some point. But we can do that.
I love both cities, but yeah, they're quite different cities.
Yes, I think I spotted a data anomaly in your analogy.
Okay, I forgot where it was, but yeah, they're both great cities.
Cool stuff. Okay, now we're going to move over on to Stan, from who's the president of TRAFAC, also from the University of Maryland. And Stan, over to you.
Yes, thanks for the introduction. First, I want to explain the relationship. Back in 2008, University of Maryland, we helped develop a new method of measuring traffic travel time. It was based on Bluetooth technology, and since then we've rolled it out into a startup company that develops Bluetooth traffic monitoring equipment systems and studies. And most of my comments today are primarily from working in specifically freeway and arterial traffic monitoring. Could you go to the next slide, please? When I was first invited to this panel, an image came to mind, and this is what the image is. It's you know, it doesn't look remarkable to begin with. It's actually about 5 to 7 years old. This was a graph we put together probably back in 2009 timeframe when we were first developing Bluetooth. It has 3 types of data on it. When you think of big data, big is a relative word. So big is anything that is larger than what you're used to processing, that breaks your tools, that makes you forces change in the organization, and that's kind of what I label big data. On this graph, there's 3 technologies. The first, if you can see the little circles, is what we call drive testing. Someone gets in a car, goes up and down the roadway, and collects representative travel time. Notice there's only about 4 data points across this 4 to 5 hour time period. Also on this data, on this graph is a line graph showing what we call fleet GPS data. This is an outsourced data feed you could get from companies like INRIX or TomTom or various others that, you know, you subscribe to an internet feed, and it takes you from a few points to a solid line, kind of a jump of an order of magnitude. And then we were developing Bluetooth traffic monitoring at the time, and that jumped it from a single line to a cloud of data, so you could see not only the central tendency, but also the variation and sample the variance in it. And you know, the next step here is we're talking about connected vehicles. It'll jump it to another whole order of magnitude. Each time we jump this order of magnitude, some of our old tools just get dated, and we got to think of a new way to do things. The next slide. The next slide comments a little bit on why is it big. Well, as technology invades our lives, it can do things better, faster, and cheaper. I call it the curse of dimensionality. You have new technologies come online that extends your temporal extents, easily going 24/7, 365. In fact, we've made some interesting traffic discoveries because it was just easier to leave the sensor on for the entire week rather than to just do it for weekdays. And when we got the data in, we made some comparisons, and it was illuminating. The granularity keeps increasing, where before we'd get 15 or 5-minute summaries. Now we're down to 1-minute data and many times sub-1-minute data. Similarly, the spatial attributes, the extents, you contract with some of these firms and you can light up your entire network overnight, and then all of a sudden you go, what am I going to do with all this data? And the granularity keeps increasing, where we used to give summaries over a 5 or 10 mile stretch. We're getting down to each segment, each intersection. And lastly, the data metrics, where we used to like measure a single attribute like a loop count. We're collecting several attributes all at the same time: speed, travel time, confidence intervals. There might be temperature and everything else all coming to this. And every time one of these increases, it just creates more and more data to sort through to find your information. I often relate that early on in dealing with some of the Bluetooth data, we'd give a data set to a student to analyze, and the first question he'd come back is, how am I going to do it? It breaks my spreadsheet. It's like, well, that's what we got to get used to. The last slide I have is dealing with big data. I think the concept is kind of related to how should public transportation institutes approach it or think about it. And that's what my last slide. First of all, separate in your mind data versus information. Information is what the public transport needs, where data is the granular bits from which it's assembled. And the public transport is what I call the subject matter expert, and needs to keep an eye on the big picture. As a member of TRAFACS, I can relate a number of occasions where we're like the third man down on a subcontracting list, and we get a data collection scheme in front of us, and we're sitting there wondering, saying, what is it they really want to know? Because all we see is a bunch of sensors on a map. And trying to keep that overall theme of what information is really needed from your data and to communicate it with all the partners is a critical function that only the Public Transport Agency can provide. And when you're considering big data, you need to ask yourself, are there alternative ways to get the information you need apart from your traditional information? And that's where you need to engage some of these vendors and say, here's ultimately what I'm trying to find out. Do you have a method that's better than what I'm currently using? You also have to have a firm handle on what the information is worth, because you're going to get offers that range in orders of magnitude as cost as well as size. A decade ago, any improvement in data quality directly affected your application. Now you can procure data to any level of granularity and accuracy that you want, but each one will cost you. So ultimately, you have to answer the question, how good is good enough, and how accurate is accurate enough? And lastly, is one of the more trickier ones is, how do I assure information quality? As you change your information source and go to these new big data sources, ultimately you have to maintain confidence in the solution. There's no magic bullet for that, but that's where a lot of your subject matter expertise has to come in. Big data will change your business practice. Basically, the old tools no longer work and you need to use new tools. Sometimes you're using a different flavor of data and that messes things up. But it's always a learning process. Change is never easy. And lastly, more data does not necessarily mean more information. As always, kind of a trap to avoid is many of these technologists, they're very good at what they do, but they are not the subject matter experts. And the public transportation sector has to realize that that is their job and to keep their eye on the information needed. And that is all I have as far as an overview.
Wonderful, thank you very much, Dan. So it's interesting that big data does not necessarily lead to big information. Okay, I think we have Armand Ciccarelli on next, and then we'll move to taking any questions that we have or a final discussion, whatever we're equipped to do. Armand, over to you.
Okay, Bob. So I don't have any slides today, but I'm going to address some of the topics that were on the topic slide that we discussed earlier. From the perspective of big data, I'm going to talk about it from a public agency perspective. I think from the transport agency side of things, specifically how to make use of the data and what's the best way to go about things. Potentially, I think there's still a lot of outstanding, unresolved discussions to be had there. For example, a State Department of Transportation or an MPO perspective, there can be travel information implications. I'm not going to really focus on those. I'm really going to more focus on the planning and operational side of things. And, as Stan was just saying, I think as David also talked about, obviously, there's a lot of data. It's growing exponentially on a day-by-day basis. Especially, and it's not just real-time data, it's also all historical data. There's this massive archive with memory becoming as increasingly inexpensive. People are archiving just more and more data. And the question is how to make use of that in light of, the additional data that's coming online daily. So I guess the point is as I think Stan and David both mentioned, agencies in particular are overwhelmed. It's like trying to get a drink out of a fire hose is the good analogy. And I think that a lot of them just, in fact, haven't even really caught up in general with the idea of how to make use of data in this new environment. There's a concept, I think, and Bob may bring this up, but in some agencies have started to do it. I think we've seen it more in the private sector, but having a data officer. A lot of agencies, I think, need a traffic cop to start thinking about what are the ways to make use of data, to how to become ready for it, how to start thinking about it, how to integrate the various private and public sector resources that are providing that information, or the data, not necessarily information. And I think in some ways, in particular related to freeways, we've started to look at how to use the data. Less so, in particular, with multimodal options, arterials, transit. I think there's a lot of interest there, but I think that's the growth area right now in those areas, and those agencies really starting to focus on the information about the movement and the performance of, in particular with transit, of transit vehicles and how their systems are operating. There's a lot of new information out there related to vehicle movement, related to passenger counts, and I think agencies are starting to make use of it. It'll be really interesting to see how that data can merge with freeway and arterial data to kind of give a more multimodal perspective of what's occurring in a city, a region, a state, to see, how far up and how far down can we aggregate and disaggregate this data to make use of it. The interesting thing, though, is as I said, I think a lot of agencies haven't caught up with the idea of big data, but I think that they're going to have to really quickly. With MAP 21 coming out recently, and I really truly believe there's going to be real calls for performance-based funding, not too far in the future. I think there are allusions to it in MAP 21 and some other things that are happening, but I don't think in the long term, especially given some of the budgeting things we're seeing in the U.S. Congress, I don't think we're going to be able to necessarily rely on VMT or other traditional statistics being used to support funding. I think it's going to really start to become based on more of a performance, seeing how actually, what kind of level of service, not a traditional level of service, A, B, C, etc., but what is the quality of service being provided, and so performance, those factors I think are going to become increasingly important. As far as that goes, the question I have really is, what is the role of these agencies in actually doing their own analysis? Like Stan had just mentioned, there's so much data, it breaks your Excel spreadsheet. So I'm going to pose a question and say, is it really more the role of there becoming a new industry, an analytics industry, which I think there are a number of companies out there doing this now, but not enough, I don't think. I think there's a whole analytics industry that needs to grow up and grow up fairly quickly to provide the necessary support that a lot of these agencies, especially the smaller agencies, are going to need to really make effective use of this data. I don't think it makes sense, although agencies should have a data officer, I don't know if it makes sense for them to do all the analysis on their own. I think that there really is a reason to call for this industry to really grow up and be supported, so that these areas of expertise can be flushed out and they can be used to support a wide range of needs on freeways, arterials, transit. Like I said, there are some out there now that needs to grow. And the other interesting thing about it is having this industry grow up where they're supporting potentially a range of different types of agencies really makes you wonder what type of interagency and regional analysis can start to be done when you have groups of agencies potentially working together with these potential consultants to analyze their data. So you're not just necessarily anymore dealing with just a small set of data for my town or my city, but really getting to see more regional effects about what's going on, to have a better sense of what's really happening from a transportation perspective. So I think there's some real interesting things that could happen fairly quickly, especially given some of the MAP 21 requirements that have come out. So a couple of final things. So this begs the question. It's nice to have data, but it's nice to do all this analysis, but what's the point? I think it's having the ability to enhance decision making. Whether it's from an operations perspective, in particular, really from a planning and programming perspective, having better data about what's happened in the past to make better decisions, have greater accountability about how money's spent down the road, and even, although it's not my area of expertise, having more predictive capabilities to use all this new data to really have a combination of all your historical data, all your real-time data, and then what kind of predictions can we make? How far out can we make them? There's some really good questions as far as what's happening with that, and I think there's a lot of really smart people working on that right now. In general, I think it's about creating this feedback loop where you're learning more and more about what's going on, and then using that to better inform what you're doing in the future. It's not just a gut instinct anymore. It's not just well, we think this will work. We've got these studies that say that this is likely to happen, but to have real data, real decision quality data to support the decisions you make. So I think there's a lot of different areas that data can support. But I think in the end, it's that decision quality information. It's taking that data and doing something with it to have an end result that is going to be highly positive to a range of people. I could just go on, but Bob, I know that we want to leave time for questions, and you may have something you want to say as well, so I'll end there. Bob, you still there?
I am.
Yes, I'm still here. Sorry, I thought I just...
I'm there as well.
have a short silence.
We're all here.
Okay, Kevin's ready to jump in case I get cut off there. Look at that. Okay.
Well, I'm always like I'm like a coiled spring. Thank you for that. Can I ask a question? Hopefully we will get some questions in a minute. I have a question. Now, normally when I get panelists in for this, we have a list of people. Bob and I draw up a list of people. Who should we get on? We have a list, and everyone says yes. That's how it works. And a couple of occasions we've actually had too many panelists and had to say, sorry guys, you have to be on the next one, which is not a very nice thing to do, but it's good for us. We have more people. For this one, I asked 3 or 4 panelists that Bob and I worked out who should speak, and they didn't really want to. They found it difficult to actually put into words what they would have meant by big data. One said I could do shadow puppets, but I'm not really too sure I could talk properly about big data. I need to learn what it is. Now, my question is, I was surprised by that. My question for everybody, has the transportation industry grasped the big data nettle yet? There we go, that's my question. Has it grasped the nettle yet?
It depends on which mode. Oh, sorry. Go ahead. So it depends on which mode you're talking about. I mean, obviously, the first adopter of big data, and this goes back many, many years, is the aviation industry, because they have to know where every aircraft on the planet is, what it's doing, where it's going. And a lot of the technology for automated control of aircraft has kind of evolved that way because they need to know it. I think rail is next because it's a heavy safety industry. Trucking is coming along because people want to track loads in real time. And I think urban and passenger transport has kind of been the most recent, I won't say a late adopter because everyone moves at their own pace, but the most recent adopter. But I think everyone gets the idea that you have too many people living in too small an area in the cities. Everyone's moved to cities. More people have lived in cities than live in the rural areas since 2007, and it'll be about 70% by the middle of the century. So we got all these people, and we have to do something. So it's evolving, but I think most of the industry gets it to some extent along that continuum of earlier and further term adopting.
Oh, yeah.
Thanks, Dave. Anybody else want to add there?
Yeah, I would add to that, Kevin. I think that we've struck maybe the central issue here, that there's maybe not a strong awareness inside transportation about big data. There seems to be a huge activity in other industrial and commercial sectors where people are actually mining big data sets and coming up with information that couldn't have been possible from smaller data sets or from a single data set. And I think there are huge opportunities for transportation, but maybe we somehow need to find a way to raise awareness. I would also say that, and maybe this is a question to the panelists as well, as we have some great experts here, let's take advantage of it. You know, our public agencies, public transportation authorities actually equipped to deal with big data? Do they have the right organizational structure, and do they have the means to take the data and turn it into information?
Good question.
I'll jump in and I'll let everybody talk. That the answer is organizationally, in transport agencies, the CIO has often been very separate institutionally from the director of operations, particularly in transit agencies in North America. And there's a recognition that we use IT for payroll and invoicing and billing and managing our fleet, but it's not been operationalized until fairly recently. Again, in Canada there's CUDA, and in US there's APTA, and there's a real need to blend what the ITS America and ITS Canada are thinking about with the operational knowledge in these other constituencies to basically move that along and kind of blend, Thinking Highways and Metro as publications, for instance, have a very different perspective on where they see the industry going. I think there's a need to close that gap because it represents cost savings, which I think will drive it, and it represents better revenue potential by increased ridership for the routes you do maintain on transportation.
Hey, David.
Mm-hmm.
This is Armand. So, I mean, given what you just said, do you think the CIO is the place or the person to be leading that, or do you think it calls for somebody with a different set of skill sets, more focused on, this specific need?
Well, I think the role is, I think it's the CIO or the head data person. I think the role is changing. Frankly, physically, you even see their CIO role and the Director of Operations role have moved much closer together. There's CIOs I know that are now much more involved than they used to be in trends and operations. And I know operations people, that are coming up, that are coming out of school, and younger people are having more and more of a combined ICT and transport skill set. Even a lot of universities, I won't go through the whole list of them, even a lot of universities are starting to train these people that both understand civil engineering, mechanical engineering, but also understand the IT aspect of it. So it's an educational and awareness thing to build a hybrid skill set that's evolving. But it kind of changes by agency, but I think that's what's going on.
Yeah, I think we're...
What does ICT mean?
Information and Communications Technology.
All right, thank you.
It's actually a slight pet peeve that people don't know what that is. There is no such industry as IT anymore, believe it or not. There is no such industry as telecom anymore. Those two have been squished together in one industry for about the last 10 years, and people continue to use the old name about that, and it's no longer an accurate descriptor. It's information and communications technology, bits and bytes. That's the real industry that we got to merge into transportation, not just telecom and not just IT.
Well, I guess Kevin and I will have to stop using the telegraph and the Morse code and move on then, huh?
I thought you did smoke signals on top of the hill. You can get a smoke signal from Glasgow to Edinburgh if you go up high enough.
There you go. Well, it means your kilt's on fire, yeah?
We have
That's what they're used for, right?
Finally, no, Dave, let's not go there. We've got some questions are flooding in. We had a veritable flood of 3 questions.
Would that be a fire hose?
Oh, not far off. Yeah, the first question is, and it's from a Mr. Jesse Darko from Ohio. Hi, Jesse. The question is, can you please share an initiative in big data in transportation that has been a success? I don't know if Jesse's got any ideas himself there, but we'll ask him to speak later. But Stan, do you want to answer that one? So what's been a success?
Yeah, I'd like to share one. It came out of the I-95 Corridor Coalition, in which they had envisioned a kind of an East Coast-wide traffic monitoring system. And it was pretty much business-based. Each one of the states had dabbled in creating statewide traffic monitoring systems using traditional sensors, and discovered quickly that it was very expensive, that it was very subject to high maintenance, and that the data sharing and the burden of making it work was, more than their state budget could bear. And then in 2006 and 2007, there were several what I'll call big data ideas. These are companies out there that could harvest traffic information from a variety of sources, some GPS fleet sources, some cell phone geolocation, and others, and more or less have been approaching the states with the idea saying, hey, we can provide the information you want, but in a totally different way. The states banded together and said, okay, this is a high-risk, high-gain project, because if it works, it'll all save us a tremendous amount of money as well as give us valuable information assets. And so they put together and used their combined experiences from what I'd say mildly successful demonstration projects in the past, and put out to the industry sort of a challenge saying, here's what we're interested in, here's the information we need and the level of granularity we need it. We're really not restricting any technology. The only real restriction is you can't put sensors on the side of the road. We want it some other way. And what resulted was a procurement and a public-private partnership in the true sense of the word, in that one of these companies stepped forward and says, we think we can meet it, and here's how. And as a result, over the past 6 or 7 years, this has grown into a multi-state traffic monitoring system that is now feeding operations applications in various states, as well as set up to help them meet several of the MAP 21 requirements that are going to come online.
Thanks, Dan. And anybody else want to comment on that? And any other transportation projects have been a success in terms of big data?
Anyone's, and I'll mention ones off. I'll start. You've mentioned a couple in the U.S. I mean, I think in our case, particularly in IBM's case, Stockholm, and in some of the work we've done in London too, anywhere where we've done a massive traffic monitoring scheme or a congestion charging scheme, that inevitably involves monitoring large amounts of data in terms of where the vehicles are, and where they're going in a downtown, how many you let in at a certain particular time. I think they've been success stories. Probably the biggest success story in transport we've had on the planet that covers a lot of different facets I won't go into for time constraints is Singapore, which has been our very cooperative client, their Land Transportation Authority, where we've basically monitored metros and traffic and congestion and all kinds of factors in terms of how we modally optimize and route against one another. How do we predict traffic? So it's for transport, I'd point to Singapore, which invented congestion charging in the 1970s before they even had the IC or ICT infrastructure to start it, to basically monitor it, and they've kind of pioneered it literally back 40 years ago now. So it's again, it's not as new as some people think it is.
Excellent. Thanks, David. We've got some questions now, so Gareth, I'll hand over to you. We have at least 3.
We do, yes. The first question, we've just got another one come in. First question comes from Nick Reed, and it's this: what educational background is needed for the analysis of big data? Engineering, mathematics, statistics, psychology? Question mark.
Yes.
Good answer.
Good answer.
Particularly psychology, I think. I will let others talk again, so I've monopolized a bit, so let me sit back and see what other perspectives are there.
Well, I think psychology, because you need a good imagination for what you're going to do with the data and how you're going to turn it into information. Engineering, because you need to be able to put a structured database together. And mathematics, because you have to understand the trends and patterns inside the data.
Yep, that's a good answer. Nick Reed is from TRL in the UK, by the way.
Right, so is he a mathematician, an engineer, or a psychologist?
I'd like to add a comment that...
Go, Stan.
Okay, I was working with Darcy Bullock from Purdue. We're moving to take some of these Bluetooth traffic monitoring concepts and applying them to arterials. And the richness of the data and information we got caused him to comment, says, you know, we've been data poor for so long that we've just relied on rudimentary statistics. And now we have so much data, we kind of need to go back to the basics and relearn our statistics. I kind of maintain that you don't really need any additional knowledge base other than the fact that you are the subject matter expert, but you're now going to have such a richer data source. Be prepared to interact with your statistician and with your database administrator to get the precise answers that you're looking for.
Excellent, excellent.
Good point.
Okay, yeah, Gareth.
Can I ask you that as well?
Yeah.
We're losing you, Kevin. You sound like a Dalek.
Oh, sorry. I'll unplug myself.
Bit of a latency issue, as it were, yeah.
The other area I think in particular that we need to add to this, and it may already be included under the umbrella of what we said, is electrical engineering and computer science, because the ability to actually make use of these data in conjunction, these data sets, these massive data sets, in conjunction with one another is going to require the development of all types of new software. You know, some of, like I said, some of it's being developed now, but I think it's a non-traditional area in the transportation field in particular that I think is going to grow in need. The need for it is going to grow as more and more data becomes available and agencies want to be more involved in its analysis.
Yeah, I remember an old management adage. I think it may have been attributed to Peter Drucker, but I'm not sure if he said it. In that if you don't measure it, you can't manage it. And I would add, if you're only measuring it, you're still not managing it, and that's probably one of the big needs for big data leading to information to help us to get decision-making information. And I can also tell you a story that's nothing to do with transportation, but is related to Mustard's big data small information and a revelation. Would you like to hear it?
Yes, go on.
Yeah. Good answer. Several years ago, Coleman's mustard, the guys who are famous for making all sorts of different varieties, including the world famous English mustard, moved away from mustard that you had to prepare yourself to pre-prepared mustard in a jar. And I guess you can still get the mustard powder in a container. And when they moved from the mustard powder to the pre-prepared mustard in jars, they expected an increase in sales, and they actually got a reduction in sales. So they embarked on a big data exercise and did a lot of surveys to find out what went on. And it led to one very small piece of information, which was that people that mix the mustard from the powder and put it on a plate or a saucer don't eat it all and throw half of it away. And if you take it from a jar or a container pre-prepared, there's no waste, so hence the sales went down. So that was the revelation that improving the packaging actually reduced the sales of the product.
Interesting. Thank you, Bob. As a left field answer to a regular question. Excellent. So, Gareth, you've got some more questions. And
yes.
Another American-based Brit who wants to ask a question.
Yeah. Well, Roy Sumner has his hand up, and I hope if I'm going to try to unmute him, if he can ask the question, I'll ask him to ask it now. You should be unmuted, Roy, if you can hear us.
Can you hear me now?
Yes, I can hear you.
Yes, we can.
Yes.
Yeah. I think to a large extent some of the things that you're talking about, as though there's this talk about drinking from a fire hose, was all addressed in the planning that we did for the original VII architecture. It isn't possible, if you calculate the total amount of information that's likely to be gathered from the connected vehicle effort, for it to be recorded. It's far bigger than any database could ever achieve or ever read, and the original intention for this data, the way that although there is things that you can do if you record all the data and you try and do lots of post-batch analysis, but the vast majority of the data, if you reflect it back to the user needs, that's going to come from things like connected vehicles, can be operated in real time. So, for example, if you have all of this data available all the way across the country and you just publish and subscribe it, and the people that are really interested in it in real time are registered and subscribed, the amount of data that each of them needs isn't drinking from a fire hose. Let me give you a current example would be the operation of the stock markets that are out there. There are hundreds of them around the world. They all have thousands of shares on them, and they're all changing all the time in real time, and people want very current information. You don't fall over backwards because you've got too much data. You subscribe to your particular stock exchange, you subscribe to a particular piece of data, and you get your real-time feed, and then all these algorithms that are doing all these tradings can gather all the information they want and they use it. If you take that same process and think about, for example, an adaptive control system that might be using vehicle profiles approaching an intersection, which is a fairly intensive data thing. In other words, if an adaptive control system were monitoring all of the approaching signals, all of the approaching vehicles, and getting trajectory data at higher data rates from them all of that information can easily be fed into the local controller, and all of the decisions made on a local level. And therefore, there's too much data to handle. In most of these places, and most of these applications, if you follow them through, and you design the system so that only data that is requested is transmitted, there is no fire hose problem.
Okay, thanks, Roy. That's a good question.
I think the fire hose has just become a whole series of water crystals.
Yeah, but that's the whole point of a distributed architecture. You don't need that data all the way across the country. You don't need to know if you're sitting in Florida, right, the trajectory of some vehicle that's approaching an intersection in Washington State. The only people that need to really know that are the people that are controlling that intersection. And the people that are controlling that intersection would be, you know, the city of Seattle, and they've got a couple of hundred controllers to deal with. And that data transmission isn't really a problem. If you, for example, want to take, you're a transportation planner and you want to calibrate an OD matrix for your inverse gravity model or whatever, if you want to do that type of stuff, you can trace the paths of all these connected vehicles, and if you calculate the amount of data that gets provided, it's well within existing capacities. As long as you say that only the people that need to make an archive are the people that make an archive, and the rest of the applications deal with data as it streams in, it's not a particular problem. I mean, I know Stan, for example, gave his example of the Bluetooth data and I-95, but he did all his processing post collection of the data by collecting the data and doing the analysis. We are doing the same thing on the border wait time project that we have, using the same equipment. It's from Trafax, it's from Stan's company, and we're gathering all data to about 21 Bluetooth things across the US-Canadian border and providing real-time data as a stream, as an XML data feed to a whole bunch of clients right now. And we don't have any processing issues at all. In fact, we monitor the processors that we have running these algorithms on the cloud, and they're running around 1 to 2% of processing time.
Good stuff. I believe we've got a couple more questions, Gareth. Is that right?
We certainly do, yes. We've got a couple more. The next one comes from Mohammed Pursastep of University of Michigan, and the question is this: vehicles will soon produce megabytes of data per km, especially with the advent of autonomous vehicle tech. What are your thoughts on handling such data? Through telematics, possibly? If so, who's going to pay for using the cellular network for such usage?
Well, I think Roy just answered the first part of the question about how to handle the data.
Mm-hmm.
Paying for it is another matter. Being Scottish, it won't be me.
Dave, that's a question for Dave, I think. God, Mr. Pickerel.
Well, I mean, I think it's going to be, I don't want to give an overly simplistic answer in terms of it, and I think it's going to be varied in terms of who uses it for what. As you'll see, remember the diagram that I have in mind, there's a lot of different users, and it depends on who's using the data at what level for what. Financial service transaction people are going to use it for electronic tolling or VMT. Highways are going to use it to monitoring. I think, and I think there's going to be a complicated flow. Again, and kind of looking at my second slide, of payments versus credits versus contributions. So I think everyone's going to kind of contribute things into the data ecosystem, and people are going to pull out what they need. Again, they're going to be, as mentioned before, they're going to be putting data points out. They will get some type of information back, and I think what they pay and how they pay will be will be based on what information they want, what they need to have for the safety of their vehicle, perhaps at a minimum, and then what value adds they want as they basically use their telematics and other things to kind of customize their own experience and do that. So it's a kind of a long way of saying there's no easy answer to that, but I think everyone will kind of do everything. There'll be a put and take on both sides, I guess, or on all parts of the ecosystem.
Oh.
I was going to comment on that. There was an earlier question of sharing a successful application. There's also, I've observed several unsuccessful attempts.
Darth Vader's in here, by the way. I'm hearing Darth Vader in the background.
This dates from about 10 years ago when data warehousing was really popular, and I observed a couple initiatives whose philosophy was, let's grab all the data we can and we'll find its value later. And those tend to have much less success because they weren't like needs driven. They weren't driven by what information we have, and it kind of plays into what Roy was saying. Is, you know, what you need to store and the size of your pipe is going to be driven by the use of the data, and not not this concept of let's gather every single bit and put it in a database for possible future use.
So
Sure.
one question that occurred to me in the discussion there just now is if our big data is big enough, is there any more need for simulation models?
Yep, that's a fair point. Fair point. Anyone want to answer that? It wasn't really a question, Bob, was it, I suppose?
It was a rhetorical question.
It's a rhetorical question, which on webcasts are not that entertaining, to be honest. It's very difficult. Everyone's just nodding. Yeah, that's a good point. We've only got time for 2 more questions, one of which is going to be mine. Privacy. I'm always interested about privacy. I know a lot of, in Europe, a lot of schemes, a lot of congestion charging schemes, ANPR schemes have been abandoned due to privacy issues. So what about privacy issues with big data? How does that work?
I don't wish to provide that information.
Okay. If anyone does want to provide that information, it will count as an answer. So Bob, so Dave, I'm going to ask you first, and then we'll get with another question from Gareth's list. So how does privacy work, Dave?
Well, again, it's going to vary by, that's kind of a legal question that varies by where you are in the world, and different countries have different views on that. In terms of, and our view as a data company is we're not in the business of trying to determine matters of public policy. We kind of support them rather than try to drive them. But I would point out that the technology is available. We're using it in our pilots around the world. A lot of our partners have it, that allow us to anonymize the data. At the end of the day, transport agencies don't really need, want, or feel entitled to know much about the people that they're driving, and their business is how many people take a ride from one end of the Royal Mile to the other in Edinburgh, or how many people ride down Fifth Avenue in New York City. And the technology today allows the provision of that information to the individual person in terms of the number of journeys that are taken from any place to the other, but there's the ability to strip out any identifying data. The analogy I like to use when I'm talking to people is when you're going on a metro or a bus or something anywhere in the world, for a split second the system needs to know who you are when you go in, tap on, tap off the system with your Oyster card, because they need to charge the correct account, just as your cell phone needs to know where you are so you can make phone calls because you voluntarily allow them to do that so they don't charge someone else your phone bill and vice versa. It's good for transport agencies to know where everyone is and where everyone travels in the system, but they have no need to store such a massive amount of personal data, even if they could collect it, because it's of no use. They just need to know what I call ridership demographics. And if we focus on ridership demographics and sheer numbers, sensors-like numbers, then the privacy issue becomes something that's best left to other domains to work out, where there's actually more of a need to really know who the people are that are doing a certain particular thing in a certain particular location, and you get on about the business of doing transit and transport rather than being in the business of monitoring people. And I think that's the safe answer to use there in terms of how it's used. But it's hard to answer that conclusively because it's just such a varied point of view around the world in terms of policy and legality of it.
Yeah, I would add a thing to that. There was a Washington Metro experience a few years ago when they introduced the smart card system, where you had 2 choices to get the smart card. You could be registered or you could be anonymous. And people who registered were given a possibility of recovering the balance on the card that was lost or stolen. And I think something like 98% of people chose to be registered and be back in return for that balance recovery feature. So perhaps privacy is tradable for other services.
Yep, it's privacy versus incentive, isn't it? Okay, so we've got about a minute and a half left. So Gareth, do you want to ask one of the last remaining questions?
Yeah, we've got one more question. It comes from James Vance, and it's this: in terms of approaches to handling or utilising big data, have there been any efforts which have failed not because the technical process was an error, but because the information generated was simply ignored by the top-level decision makers?
Oh, is anybody going to admit to that?
Good one to finish with.
I had experience with the Department of Transport in the UK a number of years ago, where they launched a major exercise to collect what was called street furniture data. Everything at the along the roadside that had to be maintained, areas of grass, drainage, asphalt surfaces, bridges, signs, lights, and having spent a lot of money collecting all this data, had a conversation with a senior guy one day and asked him what he was going to do with the data, and he hadn't really thought it through. You know, they really just wanted to get the data, and then the next stage was going to be to try and turn it into some information. So I would consider that to be a planning failure, and I think there's a major lesson there that anybody embarking in big data should have some big ideas about what they're going to do with the information and how they're going to apply it to their business processes.
Excellent. In that case, that's a good answer. Ed, do any of us want to make any final comments before I have to wrap up?
Yeah, I think we need a visualization for big data, Kevin. I think people don't understand it. We need to do like a cartoon character. I'm thinking it needs to be a St. Bernard or a St. Bernard, as we'd say over here. You know, a really big dog that's slobbering all over you and costing you a lot of money to feed unless you press it into service and get a return for your investment.
Yep. Okay. Well, I'll get someone to draw that for next time. Thank you for that. But on that rather bizarre note,
have Lewis do that.
No, that's not going to work. So thank you all attendees. Thank you very much for staying with us. Actually, the attendance went up during the webcast, which is quite unusual. So thank you all for staying. Big thanks as usual to Bob McQueen. Thanks, Bob, and to our panelists David Pickerel, Armand Ciccarelli, and Stan Young. Thanks to Gareth for fielding the questions. Lots bit of housekeeping is the next one should be in 2 weeks' time, but I will be on a plane back from Nashville in 2 weeks' time. So it's going to be in 3 weeks' time on the 2nd of May, and we're looking at machine vision. However, those of you in North America, which is virtually all of you, it's aimed more at the European market for this one. So it's going to be at 3 o'clock Central European time, 2 p.m. for me, which does mean it's 9 a.m. on the East Coast and therefore 6 a.m. on the Pacific Coast. So apologise to those of you in California or anyone west of Arizona. You probably won't want to get up and do that. So if you don't mind, but you can listen to the recording, of course. I'm not expecting you to get up.
If it's about machine vision, is it going to be a video conference?
It should be, shouldn't it? It should be done through the lens of a camera somewhere. But oddly enough, it's the irony of only having one monopoly commission. We are actually going to have the irony of a non-visual machine vision webcast. But it will be a fascinating stuff. We've got companies from Sweden, Germany, UK, Netherlands, all taking part. Hopefully someone from Gatso is going to be taking part as well, which will be interesting. So on behalf of everyone on the production team of Positive Thinking, thank you very much indeed for your attendance, and good night.